Hey everybody, it's me, Mr. Tan, and I'm right back like I left something. So I got a put the video at double speed if you are watching this. So number three here from the area between two curves was a one I some really top-notch scholars in class had asked to go over. So oops, what I wanted to look at was how we could set this up. And what I can see here is actually there's we're trying to find the shaded region. So we can see that the entire interval is from 0 to 2 pi. However, the top function switches. So first cosine is the top function from 0 to pi over 2 when they have that same output. Oh, sorry, 0 to pi over 4 went to when they have that same output of root 2 over 2, that's at pi over 4 radians, or as we know, 45 degrees, for those of us prefer to think about them in degrees. 0 to pi over 4. So that's when we have cos of x as the minus sine of x dx. But we need to then add the next portion. For the next portion, from pi over 4, where this one ended, all the way until well, this is pi, this is 3 pi over 2, so this x value would be 5 pi over 4, just a quarter more pi's than a whole pi and one less, right? This is equivalent to 6 pi over 4. So we'll do that until 5 pi over 4. And then in this case, the red function is the upper function, sine of x minus cos of x dx. And then lastly, we have from the end of that interval 5 pi over 4 to the end of the entire shaded interval, which is 2 pi. We have cos of x minus sine of x dx. So let me zoom out a bit here. What you can see is that, well, this integral, whatever we evaluate to, will be precisely the area between the two curves. So what I can do now is, if I choose to, I can open my calculator here. Of course, if you prefer to use Desmos, that's okay for now, but if you're getting ready for a situation where you may have to do this in a testing setting, when you're at the collegiate level, if you want to take some sort of a standardized assessment to get ahead in one of these things, we are going to need to know how to put it into the calculator that we could perhaps use on that test. So I'll go math integral, which is 9, finite integral from 0 to pi over 4, second this, over 4 of, this was cos of x minus sine of x dx. Okay, then I'm adding my next integral, which has an interval. Ha ha, yes. That wasn't very funny, Mr. Tannen. Why did you laugh like that? Okay, so then I got the 5 pi over 4. And so this is now the opposite. So this is now a sine of x minus cos of x. And you notice I'm doing the x and then close the parentheses. And then I got dx. And then I've got one more integral to add. My third integral, math 9. Let's take a look. So this goes from 5 pi over 4 to 2 pi, which is the end of the interval of x values for this. And this is back to my cos of x, being my upper function, minus sine of x dx. So when I press enter here, you can see it's going to take a minute to think, and it's telling me it's 5.6568 So approximately the area is 5.6. We could just say 5. What do you want to say? 5.66 if we're rounding to the nearest hundredth. And so the thing is here, we may be able to find it in a more simplified version had we gone through and done it by hand. But let's look at what the answer key does to present it in this case. So I had, where's this assignment? Okay, here's where we had the answers provided. 4 root 2, is that equivalent to 5.66? Sure hope so. Square root of 2. Okay, it is precisely equivalent. So, of course, some of you are saying, well, Mr. Tannen, since the answer was provided in that format, we could have evaluated this